Alright, today we are going to do section 4.2 notes, angle measures of triangles. Our objective is to understand angle measure relationships in triangles. For our warm-up, we'll start off with some of the material we learned in section 4.1. We are identifying triangles by sides and or angles. To identify by sides, we have three options: scalene, equilateral, and isosceles. For angles, we have four options: right, acute, obtuse, and equiangular. So going through these, the first one says we have angle measures of 100 degrees, 40 degrees, and 40 degrees. Because there is one angle that is larger than 90, that makes this triangle obtuse. We don't know about the sides, so for now we will just classify it by angles. The next one has side lengths 4 centimeters, 5 centimeters, 10 centimeters. Those sides are all different, so it is scalene. And finally, on warm-up number 3, all three of our angles are 60 degrees. If all three angles are the same, it is equiangular. Alright, for our vocab, the only three vocab words that I would worry about writing separately would be corollary, interior angles, and exterior angles. Those theorems below we are going to get to next in the notes. A corollary to a theorem is a statement that can be proved easily using that theorem. So it's just something that if we know the theorem, it makes sense because of that theorem. Interior and exterior angles of a triangle are pretty intuitive. The angles inside the triangle are interior. The ones on the exterior are outside if you extend the sides of a triangle. So here is an exterior angle. There's another one here, and a third one here. And they could all be different measures. The important thing is to only extend each side of the triangle on one side of it, so we don't cut through the other angle and produce more. Alright, our first theorem is the triangle sum theorem. The sum of the measures of the angles of a triangle is 180 degrees. So on any triangle you have, if you add up all three interior angles, you'll get 180 every single time. So measure of angle A plus measure of angle B plus measure of angle C equals 180 degrees. Make sure you get this in your notes. Let's practice some examples using that information. I know if I add up all three angles, I will get 180. So I don't know the measure of angle A, but if I add the measure of angle A plus 25 plus 15, I should get 180. And then all I have to do is solve. Measure of angle A plus 40 equals 180. Therefore, the measure of angle A is equal to 140 degrees. You can write out all your work this way, or if you want to simplify it, on number 2, again, we know they should all add up to 180. So if I take 180 minus 61 minus 59, that's going to give me 60. So that means for the second problem, the measure of angle A is 60 degrees. On this third one, again, it's the same thing. They all have to add up to 180. So we take 180 minus 34 minus 56. That is going to leave us with 90. So the measure of angle A is equal to 90 degrees. Next, we've got the corollary to the triangle sum theorem. If we have a triangle with a right angle in it, then the other two angles have to be complementary to each other. So if angle C is 90 degrees, then if we add A and B, they should also end up equaling 90 degrees. We get that because all three of them together would have to equal 180. So if one of them is 90, that leaves a total of 90 degrees to split between the other two angles. Let's use that on example 4. In this diagram, we've got two right angles, and we know the measure of angle ABD. So this angle here is 35 degrees. The first question asks me to find the measure of angle DAB. So that is this angle here. In order to find that, I see that I have a right triangle. So I know that the other two small angles inside of it have to add up to 90. That means that the measure of angle DAB plus 35 is equal to 90. I can solve that by subtracting 35 from both sides. We get the measure of angle DAB is 55 degrees. On letter B, we are asked to find the measure of angle BCD. That's this angle over here. In order to find that, I can use the fact that I figured out that this angle is 55 degrees, and the fact that I've got a right triangle, the larger right triangle. Okay, so now I can see I have a larger right triangle. These two angles here have to add up to 90. So I can just take 90 minus the 55, and I get that the measure of angle BCD is equal to 35 degrees. Alright, these are more of the same. They're all right triangles. We're given one angle. We're asked to find the other. So in order to do it, we take 90 minus the angle they give us. In this case, the measure of angle A is equal to 73 degrees. On the next one, 90 minus 65. We get that the measure of angle A equals 25 degrees. And on the last one, it's the same setup. 90 minus 45. The measure of angle A equals 45 degrees. Alright, our last theorem for today, the exterior angle theorem. We've got a wordy definition of it, but basically what it says is that this exterior angle is equal to the sum of the two interior angles that it does not touch. So the exterior is equal to, or is the same as, if you were to add the two interior angles that are not next to it together. So that's what we're going to do. We are going to use that same idea. Exterior equals interior plus interior on all these problems. Now on this example, they give us the exterior angle. So 131 equals interior plus interior. 112 plus the measure of angle 1. Remember, this does not have a degree symbol, so it names the angle. It does not give a measure in degrees. When we subtract 112 from both sides, we get that the measure of angle 1 is equal to 19 degrees. On the next problem, now our exterior angle is the one that we do not know. So the measure of angle 1 is equal to the sum, or if we add the two inside, 60 plus 60. Measure of angle 1 equals 120 degrees. On the last one again, the exterior one is the one outside. And we add up the two inside, 90 and 20. When we add those, we get 110 degrees for the measure of angle 1. Alright, that's it for our 4.2 notes. Make sure you go back and rewind and pause it if you need more time on any definitions, theorems, or examples.